This time we are going to solve problems that require us to use the entire flowchart. So in this case we have how many grams of hydrogen gas are required to make 37 grams of water. So 37 grams of water is our given. Notice how I underline everything. I underline the number, the unit, as well as the chemical. Then we are looking for grams of hydrogen. Again, I underline the unit as well as the chemicals. So this is our given, and this is what we are looking for. So this is where we are going to end. Now going back to the flowchart, find the box that has grams. In this case, A is our given, so this is where we are going to start. And B is what we are looking for, so this is where we are going to end. In this case, we are looking for grams of B, which is right here. So we are going to start from mass A, going all the way to mass B. We follow the arrows, going from A to B. So basically, our given number will times 1 conversion factors, 2 conversion factors, and 3 conversion factors. In this case, our given is 37 grams of water, so we have 37 grams of water, times the 3 conversion factor up here, 1, 2, 3, so I'm going to draw a 3 line. Now what we have is, based on the conversion factor, this is our first one, second one, and third one. So the first one is 1 moles of A equal to the number of grams of A. Now what is A? A is our given chemical. In this case it is water. So A is going to be replaced with water. So 1 moles of water equal to the number of grams of water. What does this number represent? This number is equal to the molar mass of water, or the molar mass of the given chemical. In this case we have water. And how do you find the molar mass of water is that we have to list the elements in water molecules, which is hydrogen and oxygen. Then we count how many moles of each element do we have. We have 2 moles of hydrogen, and we have 1 mole of oxygen. Then we multiply by the atomic mass on the periodic table. Hydrogen is 1, oxygen is 16. So we have 2 times 1 is 2, and 1 times 16 is 16. Give us a total mass of 18 grams of water. So therefore this number is going to be 18 grams of water. Now after the first conversion factor, this one is done. We are moving on to the next one, which is the number of moles A equal to the number of moles B. So in this case, our A is water again, so it's going to be H2O. And our B is going to be the elements that we are looking for. In this case is hydrogen. So how many moles of water do we have in this ratio? In this case, we're going back to the chemical equation right here. And we're looking for water, so we circle water. And right in front of water, we have the coefficient 2. That coefficient indicates there are 2 moles of water in this ratio. The same thing for hydrogen. We go back to the equation and look for hydrogen. We have 2 right there. So therefore, this is going to be 2 moles of hydrogen as well. So we are done with these conversion factors. We are moving on to the next one, and the last conversion factor is 1 moles of B equal to number of grams of B. Again, B is the chemical that we are looking for, which is H2, and over here it's going to be H2 as well. But how many grams of B do we have? Going back to your flowchart, that number of grams is the molar mass of the chemical. In this case, we have hydrogen, so we list hydrogen, and there are 2 of them, and timed by the atomic mass on the periodic table will give us 2 grams of hydrogen. So this is here going to be 2 grams of hydrogen. The next step is to substitute everything in. We start from our 37 grams of water, time our first conversion factor, which is right here, So in this case, we're going back to that golden rules where we have the previous unit and the bottom unit has to be the same. So we have grams of water, so down here has to be grams of water as well. Going back to your flowchart, this side has grams of water. And exactly 18 grams of water. If the grams of water is on the bottom, the top has to be this side, which is 1 moles of water. So we are done with the first conversion factors. Now we're moving on to the next one, which is this one right here. Now the previous unit is no longer grams, but is now mole. So we have to have moles of water on the bottom. In this case, this side has moles of water. Now in this part, the chemical becomes very specific because both sides has mole, but only this side has moles of water. So we have 2 moles of water. If 2 moles of water, if this side is on the bottom, the other side has to be on top, which is 2 moles of hydrogen. So we are done with the second conversion factor. We are going to move on to the last conversion factors. So the previous unit is no longer 1 moles of water. Now it is 2 moles of hydrogen. So down here has to be moles of hydrogen as well. So you go back to the flow chart and look for moles of hydrogen, which is this side. So we have 1 mole of hydrogen. If 1 mole of hydrogen is on the bottom, the top would be 2 grams of hydrogen, which is the leftover. Then we have our substitution done. The next step is to cancel out the unit. So we have grams of water cancel out with grams of water. We have moles of water cancel out with moles of water. We have moles of hydrogen cancel out moles of hydrogen, and we have grams of hydrogen left. In this case, we are going to multiply everything on the top first and divide it by everything on the bottom. So we have 37 times 1 times 2 times 2 grams of hydrogen. And then we're going to divide by everything on the bottom. So we're going to draw a long line. So 18 times 2 times 1. So we have 18 times 2 times 1. And this is our final answer.